So today's lesson is in section A.3b. So we looked at A.3a yesterday. This one's going to focus on rational expressions. We're going to multiply and divide rational expressions, and then we're also going to use the least common multiple to help us add or subtract our rational expressions. So just a few things here. A rational expression is the quotient. So when we talk about quotient, we're talking about the division of two polynomials. So an example of that would be 3x plus 1 divided by x squared plus 5. If its numerator and denominator have no common factors, then the rational expression is simplified. So one of the things we're going to be doing today is simplifying these rational expressions. So if possible, we're trying to find any common factors and then simplify them. Once we've done that, then that expression is completely simplified. So in order to do that, we are going to need to make sure that we can factor the numerator, we're going to factor the denominator, and then once we have done that, we will cancel any common factors. So if we look at our first example here, we have 3x squared minus x minus 2 divided by 3x squared minus 7x plus 4. So we need to factor those. So if we use our methods from the other day, I'm looking for something in the numerator here that will multiply to be negative 6, add up to be negative 1. And so in this case, we would have negative 3 and positive 2. So we have 3x squared minus 3x plus 2x minus 2. So doing our grouping method from the other day, we have a GCF of 3x from our first group, leaving me with x minus 1, and a positive 2 as our greatest common factor from the second group, leaving us also with x minus 1. And so our factors in the numerator are x minus 1 and 3x plus 2. In our denominator, we do a similar thing for that. So 3 times 4 gives me 12. I'm looking to add up to be negative 7. So we would have negative 3 and negative 4 as our two numbers. So we have 3x squared minus 3x plus 4x sorry about that. Let me switch that. 3x squared minus 3x minus 4x plus 4. Grouping from the first two gives us a GCF of 3x. So x minus 1 is our factor there. In our second group here, we actually want to take out a negative 4, and so that leaves us with x minus 1 as well. So those factors are x minus 1 and 3x minus 4. So then in order to rewrite this rational expression in a factored form, it would look like 3x plus 2 times x minus 1 divided by 3x minus 4 times x minus 1. And since we have a common factor of x minus 1 in both the numerator and denominator, we can simplify, and so we are left with 3x plus 2 over 3x minus 4. Now, one thing that you might have done in your Algebra 2 class that we'll just briefly talk about here are the restrictions on this rational expression. So restrictions have to do with values of x that we can use. Now when we're dealing with a fraction, we cannot have a value of 0 in the denominator. And so if we look back at this right here, those are the factors of our denominator. And what would make each of those factors 0? Well, if x minus 1 equals 0, that means x would have to be 1. If 3x minus 4 were equal to 0, then the whole denominator would be 0 as well, because this quantity of 3x minus 4 being 0 multiplied by whatever this quantity is would end up still being 0. Well, this gives us an x value of 4/3. So in terms of restrictions on the domain, domain meaning the x values of this function, we cannot have x equal 1 and we cannot have x equal 4/3. Those are restrictions, and as long as that's the case, we have a legitimate rational expression. Alright, so here's our next one. You'll notice that we are multiplying. So we want to try and cancel common factors. So once again, we're going to try and factor what we have here. I'm going to pause or have you pause the video for just a second and try and come up with what the factors are on your, by yourself. So if you will pause, and then I'll start back up shortly. Okay, so hopefully you've had a chance to factor here. What you should find is that in the numerator here we have factors of 2x plus 3 and x plus 2. In the denominator of the first fraction, we're going to be able to factor out an x, leaving us with x squared plus 1. Nothing that we can factor in the numerator of the second fraction. In this one here, we are going to have x plus 2 times x minus 1. So in terms of what we can factor there, we can simplify this x for that x. We can also simplify that quantity of x plus 2 with this quantity of x plus 2. And so our answer is that we have 2x plus 3 divided by x squared plus 1 times the quantity of x minus 1. Okay. And that would be our answer in a simplified form. All right, so here we are dividing. This might look a little complicated written like this, where we have fractions within fractions. My suggestion is to rewrite it like this: x squared plus 6x minus 27 divided by 2x plus 4. Put your other divide symbol right there, and then we would have x plus 9 divided by 2x squared plus 8x plus 8. Now, when you are dividing fractions, dividing is the same thing as multiplying by the reciprocal. So I can change this to a multiplication problem where 2x squared plus 8x plus 8 is in the numerator and x plus 9 is in the denominator. So from there, I'm going to give you once again a moment to try and factor each of those parts, and we'll come back in a second and see how you did. Okay, so we're back, and you can see that in blue here I have the factors completely factored out, and so now it's just a matter of simplifying. So what can I simplify? I've got my x plus 9s, I've got an x plus 2, and then I've got this 2 and a 2 here. Now you'll notice everything in the denominator is simplified, so when that happens it reduces to be 1 in that position, and so what is left is x minus 3 times x plus 2 over 1, which is the same thing as just saying x minus 3 times x plus 2. Alright, so now we get into adding rational expressions. And so if you think back to adding fractions, in order to add things you need to have a common denominator. And the nice thing about this problem is that it already starts out with a common denominator. So that means that I can combine these two expressions by addition with the same denominator of 2x plus 7, and so my numerator, I take the values from those and add them together. Well, that gives me x squared plus 5 plus x minus 7. I can do a little combining of like terms, and so I end up with x squared plus x minus 2 divided by that 2x plus 7. Restriction on this one, so if we just talk about the restriction here, x would not be able to be negative 7/2. A value of negative 7/2 would make our denominator 0 if we plugged in that for x, and so that value is not part of our domain. So that one was a pretty easy one because the denominators were the same. We'll look at one where they're not. If they're not, we have to create a least common denominator that includes any binomials or any of the prime factors of our denominators. And so looking at this, what I would need to do is take 2x squared over x plus 9, and I would also need to have that same binomial that's part of the other fraction. And so what I'm going to have to do is I'm going to have to multiply x plus 9 by the quantity of x plus 2, but if I do that in the denominator, I also have to do it in the numerator. I'm going to do the same thing for the other fraction. So I had the 1 divided by x plus 2 here. In order to have a common denominator, I need to multiply both the numerator and the denominator here by x plus 9. So now what that gives me, if I distribute, I have 2x cubed plus 4x squared minus, and notice I'm going to put this in parentheses here because I'm subtracting this whole polynomial up on the top. I'm going to subtract x plus 9. And all of that is over my least common denominator of x plus 9 times x plus 2. And so my final answer here would be 2x cubed plus 4x squared minus x minus 9. Divided by my least common denominator, x plus 9 times x plus 2. The numerator is possible. It's possible that you could factor that one, so you want to check to see if that could somehow happen. If we were to do that here, I don't think that that problem would factor and be able to be reduced with anything in the denominator, so we are just going to leave it like that. In terms of restrictions, x would not be able to be negative 9, and it wouldn't be able to be a negative 2. All right, one more here. Once again, we're adding these two. You can see that the denominators are different, so we don't have a least common denominator at this point. In order to determine the least common denominator here, we first need to factor. And so if I'm factoring my first denominator here, I would have x plus 3 times x plus 1. And then in this denominator, I have x plus 3 times x plus 3. So in order to have common denominators, I would take my first fraction and if there's any binomial that I don't have in this fraction that is part of the second fraction, I need to include that. Now, I have an x plus 3. The problem is that in this other one I have two x plus 3 quantities that I'm multiplying by. So I would need an additional x plus 3 in that first denominator, which means I've got to multiply it by x plus 3 on the top as well. Second one, I've got this 3x minus 2 in the numerator. I've got x plus 3 times another x plus 3, and I need to have this denominator be the same as the first one, which means I also need to have an x plus 1. And so I'm going to need to multiply by x plus 1 on both the top and the bottom. So I do some distributing in the numerator, which gives me x squared plus 3x. And then over on the second one, that's going to give me plus 3x squared plus 3x minus 2x minus 2. And all of that is over this LCD of x plus 3 times x plus 3 times x plus 1. We can do a little combining of like terms, so it looks like that what we have is 4x squared plus 6x, nope, plus 4x minus 2 and so we have 4x squared plus 4x minus 2 divided by the quantities of x plus 3 times x plus 3 times x plus 1. All right, here's your assignment. If you have further questions, come see me.